Welcome to Integrity's April XSS Challenge write-up video. And right now you're not seeing me on the screen, and that is because you are seeing something different, because for this month we wanted to do something different, and we've invited 4 incredibly talented hunters onto this video. We've pretty much asked them to record their screens. So right now on the screen you are seeing their view of the challenge. We asked them to solve the challenge and record themselves while solving it, and that is what you are seeing right now. This video will be a bit different from the other ones because we are going to go into the perspectives of these hunters, how they solved it. Some will explain some things on their own, but nonetheless there is a lot to be learned from looking at these pros and how they handle everything. So without further ado, let's pass the mic on to RS, who is going to talk us through the first things that he does when he's looking at a challenge. So let's get going.
Let me show you a little bit of my methodology and the way I usually approach a challenge. So we have the integrity challenge open here. And of course, I guess everyone does this. The first thing we do, we're just gonna start, interacting with the application and see, how it behaves. Right, so we have here the application. Let's open developer tools. Let's check the page. Right, let's check the code of the application. And I looked at this before, so I kind of know what's going on. But usually the things that I use the most when checking these challenges is the debugger, right? And so, of course, with the debugger, you're gonna need to set breakpoints and whatnot. So we see this nice function here that parses the query string. So of course, this is interesting, right? This might be a source for an XSS.
Thank you, RS, for showing us around the application. We'll come back to you later, but right now I want to focus on that code because RS said that this code was interesting. And that is very, very true because this whole web page is built and works using this little piece of code. And that is probably where we are going to find our vulnerabilities to get an XSS. So let's look into it. It starts off with a parse query string of our location.search. Now, this is pretty much just going to get all of the get parameters in our URL and just parse them and make an object out of them. So that is great. It's just going to parse or get parameters. So that means that this is some user input that might be used somewhere in this code. So that is already great. Well, following that, it's going to create an object app config, and it's going to create that object with object.createNull. Now remember that because that will be important in the future. Besides that, it's also going to set a bunch of properties on that object, the version, the mode, the window name, and so on. Note the types of these properties. We have a number, a string, an array of strings, and a boolean. Following that, it's going to check if qs.config, if there is a get parameter config. If that is the case, then it's going to merge app.config with qs.config. And merge is a custom function here that if we scroll down to, we can see right here. It's quite convoluted here, but really simply put, merge is just going to merge the two objects together. So let's say we have an object test1 and test2. Test1 has the property A set to a value, and test2 has the property B set to a value. If we merge the two objects together, we'll get an object that has both the property A and the property B set. And that is pretty much what this merge function is going to do. More about that function later. But for now, what's good to know about this merge function is that this is a place where our user input is actively being used and put in an object. So that is obviously very interesting. After that, we're going to create a new object, again with object.createNull. And this one is called the dev settings. Now, the dev settings have a bunch more properties, one of which is an element, document.createElement, so an element on the page. The second is a Boolean, then we have a string and another Boolean. Interesting to remember. But moving on, we also have another if statement. This time it's checking for checkhost, and if checkhost is true, then it's going to perform another merge. Now that merge is interesting because obviously user input is being used there, so let's see when this checkhost is true. And looking at the checkhost function, we see that checkhost will be true if we are on the local host or if we are on port 8080. And well, neither is the case here. We're attacking a page that is hosted not on localhost or on 8080. So that is a bummer. We probably won't be able to get there. Following that, we have another if statement, and in this if statement, there's going to be some console logs, and this is just a debug statement, but it's logging out those objects that were created earlier. After that, we have a pretty big if statement, and this one is going to do some m.mount stuff. Well, what does that mean? This whole code makes use of Mithril.js, which is a framework for building single-page applications. So this is pretty much just making use of that framework to put all of the components together, because right at the end, you can see the document.body.appendChild of devsettings.root, and this is where the whole object that we've just built will be put onto the page. And that is how it's building this thing that you see. This window that you see is being built from all of these values, putting together. It's then mounting them onto devsettings.root and then putting that into the DOM. A couple things to note here is that we have user input being intertwined into these objects, which is very interesting, and that at the end, all of that ends up in the DOM, which is also very interesting. So obviously all our players checked out this code as well. Let's see how they looked at it and if they found something interesting. Let's go to GoatSniff and see how he reacted when he first saw this merge function.
We're dealing with objects in a pretty odd way here, but fair enough. It's just a different syntax. All right, we definitely have to make some notes. So merge appconfig and qs.config. Merge sounds interesting. Object.create null. What? There's surely something interesting related to this. Or maybe they are trying to create an object with some particular stuff that I'm not aware of, because normally you would just create an inline object or you would just do new object. I've never seen object.create, or maybe that does something I don't know it does. Dev settings root, blah, 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 blah. Check host. Oh man, there's way too much to play with. Dev settings. Dev settings. We're seeing a lot of dev settings. That sounds like a juicy one. m.mount. Wow. We're mounting. Presumably also in a similar way to React. But it's mounting dev settings. Oh, .root. Okay, so presumably something gets stored in root. Ah, there you go. An element gets stored in root. And then app. Presumably that's just boring as well. Window name, window content. I wonder if these relate to the actual library, window-name. And this app config may be like a thing they use. Oh, this is going to be a long document read. Check host. Temp, location.host.split. Okay, now this looks like a juicy thing to touch as well. See if we can trick that. But location.host. Is that just this part? I'm just trying to test a few things, get an idea of what's going on before I... Okay, no, it's the entire domain. Interesting. So it includes the port, but could you slip whatever. We'll figure that out later. But it's doing something interesting whenever you're on localhost, presumably. Check host. Number. Man, that's some weird logic. I'm not even sure what that's doing yet. Is primitive. That doesn't look particularly interesting, but maybe that will be useful later. This is looking... Oh, man. Is this going to be prototype pollution? Obviously, there's an effort here to protect particular values, and merging is such a typical prototype pollution function. So we may have to look into getting some weird stuff out of this. M is in there. That's very interesting. Okay. So that's all part of merge. They're all doing a big merge here. Oh, is that recursive? Where does this end? We'll look at that later.
Okay, he immediately thinks of prototype pollution, and he would be correct there. We can set whichever property we want on these objects, and that obviously leads to prototype pollution because we can pollute the prototype and start overwriting values on the object, for example. But it's not as easy as just doing that because there is this protected keys array. And let's cut to Goku Kaioken, who is going to go through how he found a bypass for these protected keys. As you can see in his video here, he says that proto won't be allowed as a key regardless because this patch here prevents that, and that is this protected keys array. It prevents us from accessing the prototype. Now, he also says that we have to find another way to achieve this without __proto___. So he goes to Google. And I'll speed up this section here because he does a bunch of Googling, but eventually he finds something interesting. He finds that using constructor and then prototype, you can still access the prototype without using __proto__. So that is great. He has just bypassed this whole protected keys check, and that's a huge step because now we can start polluting prototypes. Right? Well, he does some more researching and eventually he types this comment. Cannot pollute app.config or dev settings because they are both created using object.create null. We talked about this earlier, but now we can finally get into why this is an issue, and GoatSniff discovered that in his video, so let's cut to GoatSniff again to let him explain.
So this object.create null thing is pretty weird. Let me try and understand why they're doing this weird way of doing things. So let's check the MDN. So object.create method creates a new object. Who knew? Using an existing object as the prototype of the newly created object. Oof. Now, does this aid in prototype pollution or does this hinder us? I'm not really sure. So we passed in null as our prototype. So in this instance, they are setting up a person object with a bunch of values and methods, and then me is a created. Basically, it's like an old school Java class kind of thing where you set up a person and then you say this is going to be a new version of the person. But again, I don't see why you wouldn't use like new keyword. Interesting. So presumably, given that it's null, it doesn't inherit anything. Let's try that out. So if we do object, well, let's do new object. Let's do var so I can overwrite it. Var and just call it test because I am literally testing something. So test is an object and we can say test.toString is the obvious one. Object. Makes sense. So let's try a new object, and instead of doing that, we would do object.create and then null. Great. So test is once again an object. Can we .toString test? Just as I thought, we cannot toString test because it doesn't inherit from object anymore. It inherits from null as its prototype. Which sounds like it's there to hinder prototype pollution, which has been my exciting idea.
But what does that mean for us? Well, usually we want to pollute the object prototype, but in this case that won't be possible due to the fact that these objects are created with object.create null, so they don't have that object prototype. That is an issue, obviously, but there might be a way to work around that, because these objects, they have properties, and these properties might be of an interesting value that we could pollute. Now, most of these here are primitives, which don't help us that much, but there is this dev settings root property, and this one is a document.create element, so that it's an element in the DOM. Now, if we can pollute an element in the DOM, then we can obviously set the inner HTML and all that kind of stuff, and we can probably easily get an XSS to go that way. Now the question is, can we pollute dev settings? And well, this merge is run on dev settings with our input right here, but for that we need to pass the checkhost function, And the checkhost function, as we discussed, can only be passed if we're on localhost or on port 8080. So that's an issue. But let's see how Goku Kaioken went around that and what his thought process was when looking at this function. Before we start digging into this specific prototype pollution issue, we want to make our work easier to debug, because we are going to be polluting the prototype of app_config, which is an object, and I am no expert in prototype pollution, so I'd like to visually see what this object looks like after it gets created. Luckily, after our vulnerable merge, there is also a console.log statement of this resulting object that I would like to see. However, for us to reach that, for it to be printed out, the dev settings need a specific value for isDebug. It should be set to true, but by default it is set to false. Now, luckily, there's also a call to merge our input into the dev settings where we could potentially change that. But for that, we need the checkhost function to return true. And if we look at the checkhost function, then we see that we need to be on the local host or use port 8080, and well, we don't. It looks like there is no real way to get that debugging output, and if you think that, you would be correct. However, all of this is happening on the client side. This is our PC and we control it, so we may be able to pull something off here. And let's cut to Efreet's view, because that is exactly what he set up. He opens up Burp Suite and he intercepts requests. Now in his proxy, he's going to go to the Options tab and scroll down to Match and Replace. Here he's going to add a new rule of the type response body. But hold up, what is this Match and Replace of Burp Suite? Well, it's simple. For every request going through the proxy, it's going to see if a certain string is present in the request, or in this case in the response, because that is what this type sets. It's going to look in the response for that string and replace it with a string that you supply. So in this case, let's see how Efreet sets it up. He's going to match for the line where the isDebug setting value is set to false, and he's going to replace that to true. This way, even though the server is sending that the debug mode should be disabled, in fact, it's going to be enabled. Now, let's see if that works. And it doesn't at first, but Efreet quickly figures out that caching is the reason, and that when he changes the URL slightly, that it does actually work, and that is great. We now have some easy debugging setup to look into our objects that we are polluting, and right now we can finally really get into this prototype pollution. Let's get back to business here. Do you still remember that we need to bypass this checkhost function, because then that will give us access to pollute this other settings object that has an element in the DOM, so that way we could try to pollute the element in the DOM and get XSS that way. Let's see how Goku Kaioken went about that. So first of all, he's looking at this checkhost function and he types in a comment saying that he might be able to pollute the array here, and then he goes and does a bunch of research on prototype pollution on arrays. Now he's going to go into his console and he's going to try a bunch of things out to eventually settle on making an array, then setting the constructor, prototype, and then the first element, and you can change that to anything you want. What is the result of that? Well, since you've polluted the array prototype, whenever another array is made with, for example, only one element, then the 0th element of that array is obviously going to be that element it was created with. But the second element, so 1 between square brackets, will not exist. So it will look in the prototype to see if it exists there. And it does, because you have polluted the prototype. And that is the whole idea here. Now, why does that work? Well, our object that we can pollute, it has this toolbar. And this toolbar has min, max, and close as values in the array. And these are just given in the URL. So we can very easily just remove the max and close from that, so that we have an array of length 1, so only having a 0. And then we can just pollute the other one, because we can set config window-toolbar, then constructor, prototype 1, and then we can set that to 8080, which would result in, if we look back at the checkhost function, for this temp here, it's going to look for the second element, But that second element doesn't exist because we don't have a port in our URL. So that is not going to exist. So it's going to look in the prototype of array, which we have already polluted. And there it's going to find that this value should be 8080. And thus it's going to take the value 8080, bypassing this whole function, making it think that we are on localhost 8080, which is not true. And well, that is a crazy bypass. And the funny thing is that Goku Kaioken was even surprised by this. So he goes into his terminal when it works and he says, huh, that worked. That's really cool. And I like seeing that because he tried a bunch of stuff here. He spent a bunch of time on this and eventually got an answer. And that is great. Now we only have one thing left to do, and that is pollute these settings so that we can pollute this element that's in the DOM and get an XSS going. So let's look into that. Time to solve this challenge. Now we can finally pollute the dev settings, and if we look at this object in our console, we can see that it's an object which has is debug, is test host or port, it has location, and it has a property root, which is an element that we have been talking about all this time. Now we can very easily access this root element and even change it. But what would we want to change about this element? Well, the first thing that comes to mind is to change the inner HTML. That would obviously be a great thing to do because then this element gets rendered onto the page and, well, with our inner HTML, we could easily make it pop an alert for us. And you can try that out, but that won't work. Now, why is that? This won't work because we are still using that mithril.js to display everything on the screen. And in this section of code, we're mounting devsettings.root onto the app, and that is overwriting the inner HTML once again within the mithril.js code. So we cannot use that. So I talked about how a lot of people got stuck here, and Efreet also got very stuck here. He spent over 2 hours trying to get around that and get this XSS to pop. He tried a bunch of stuff. He tried going into the V nodes of mithril.js. He looked into all of that until he eventually found a solution that uses outer HTML to get this to work. However, that solution still is unintended. And this all happened before you guys got access to the challenge. So the creator decided to patch his solution out because the intended solution here is way, way longer and involves a bunch more steps. But you guys quickly figured out a bunch more unintended solutions and nobody found the intended solution. So we're going to keep that secret for now because the creator might want to do a revenge version where everything is patched and you have to find the intended solution. So be on the lookout for that if you want to compete and try to find the intended solution. But for now, let's look at an unintended solution and how you guys could have solved it on the version that was running for this challenge. So okay, what is the solution in the end then? And I'm just going to show it to you and then explain it. So for our settings root prototype pollution, we are not just going to be polluting outer HTML. No, in this solution, we are going to be polluting owner document. Now, what is owner document? Well, owner document is the document that owns this element. In this case, well, just the document of the page. Then we can go into the body, so take the body of the page, into the children, and grab the second element in this case from the children. So now we have an element that we can control and that mithril.js won't mess with. Then we are going to set the outer HTML of that to our payload. Our payload in this case is just a simple image source is something that doesn't exist, and then the on error is an alert document.domain. But you might wonder, what is that? What are those square brackets and that 0 doing there? What is all that about? Well, in this patch, some sanitization got added here. And here we see the code for the sanitization. And quickly take a second to see if you can spot the vulnerability in that. It's fairly easy because it's only checking strings. So if a string gets passed into the sanitization function, then it will replace all the vulnerable characters and change them. But what if we don't pass a string to that? What if we pass an array to that? Then it will just return the data as is. So in this case, the solution includes making that outer HTML an array and setting the first element to our payload. All of that will obviously end up in the DOM and trigger the XSS. And that is how this insane challenge got solved. Note that this is still unintended, so the intended route is even more difficult. But this was a solution that worked, so if you found this, a huge congratulations. There are also a couple of other types of unintended solutions out there, so be sure to check the Integrity Twitter to find all of the write-ups and to read or watch what others have created, because on these challenges, a bunch of people like to write their own write-ups, so check all of them out as well. That was it for this challenge. Thank you all so much for watching. Thank you for competing in the challenge. A huge thanks to Huli for creating this one, and a big thanks to _RS, to GokuKaioken, to GoatSniff, and to Efreet for willing to participate in this and send me their recording and how they solved the challenge. That was really amazing. This video was a lot of work, but I think it turned out quite nicely. If you think so as well, then let us know in the comments. Like this video if you liked it. And for now, I'm gonna say goodbye. But you will notice that the video is not over yet. And that is because GoatSniff and RS still want to show you something. So I'll add 2 bonus sections here. One from RS where he talks through his debugging process and how he was able to get the debugger to work. And then also a section by GoatSniff on note-taking and how he did all of that. But for me, it's a goodbye. Enjoy the rest of the video, and I hope to see you back in the next one.
Let's put a breakpoint, right after the functions runs, and see what's going on. Right, so we set up the breakpoint. Click here, and everything looks fine so far. Right, we can see the QS object. Yeah, if it's an object, we can see all the the values from the query string. Now the issue is here when we want to change some value. For example, we have the window content here, right? Window content, which is test1. Let's change that to test2. Right, the breakpoint does not get hit, and if I want to check the QS object that's from the query string, I'm not able to do it at this point. This is annoying, right? If you want to do that, you want to click again here in the page source, go to that function here, put the breakpoint again, and refresh the page. And it's kind of annoying. You have to do that every time you're editing the URL. So there's a couple of ways to bypass this. So maybe the simplest way to do it, right, is to just download the site locally and edit the files and put the breakpoints locally on the files, right? So let's do that, just to see how it behaves. So what do we have here? We have an HTML page, right? We have the window maker HTML. Let's check the network. Right, let's clear the log and see again what's. Oh, we hit the breakpoint. So let's go to next. What do we hear? We have a CSS file. We have a JavaScript file, right? We have a background image. We have a font that's missing. Maybe we don't need that, but so let's run this. You can see the sources here also. Let's run this application locally. So first thing, let's download the window maker file, or let's actually make a directory here. So I'm in the challenge. So we opened, right? Oh, sorry, forget about this. So let's close this. We have the domain, the first page of the application. Let's save it, Control S. challenge. So we're gonna save it as, we have a couple of options here to save it as. We have a single file, web page complete, and HTML only. We're just gonna do HTML only for now. We're not messing out with the other options. So let's save. And what else? What else do we have here? We have the background image. I think we can copy image URL. Right. Let's save this one. Save image as challenge. Save. Let's look at the source of the page. So we see that the CSS files are loaded from a directory, right? And the JavaScript file also. So I think these are the only two things here. Yeah, let's save them. So we have the HTML file, we have the background image. So make the window maker files. Right, window maker files. So we can just wget here, or we can just go window maker, mithril, save as, challenge, save, and same here, CSS, save as, window maker file, xp.css. Say, I think we have everything here, right? So inside this directory where we have downloaded everything, we can run a Python script. So Python, actually it's not really a script, it's just we're invocating this server module. And so we want a Python server that's listening on port 9999 that will serve the contents of this directory, right? We have it out. And now if we go to the browser and we go to the directory, we can see the HTML file. So we click, it looks like the same, right? I don't think we have yeah, I think it's the exactly the same, right? So, of course, when we're doing this, right, when we're working on the application locally, we must assume that there is no, like the challenge, this challenge here has no server-side components, right? And from what I saw so far, there is no server-side components here, and I hope I'm not wrong. But for our purpose here to make sure the breakpoints stay on page reloads, this is gonna do, right? Running an application here. So yeah, this font. Let's get this font tool. So why not, right? It doesn't look like I know Windows XP looks. So let's download the font from somewhere. So MS Sans serif, what's this? MS copy file name. So if we Google that, no, sorry. Let's go. So let's go here. Oh no, not this one. So let's Google the font here, the font name. Oh, where is it from? Okay, so I'm just gonna copy it from here. Right, so right. Oh, look, we have an URL. I think you can just get it from here directly. So we copy the URL. We make it here. We download it here with wget. Sorry. Computer running a bit slow when recording video. So we have the we have to start also the Python server. Okay, so did it load? Oh, we have to move mass window maker files and Python server. We fixed the font issue. Not really related to the challenge, but it looks better here locally. So let's go back to breakpoints. Now that we have the application loaded locally, we can just easily use our tools here and edit. So right now, let's put a debugger statement here to make sure debuggers will stop here. Debugger. Save the file. Go back here. Right, it stopped automatically. Let's change some parameters. Stopped again. Right, very nice. We can debug the application easily. So this is one way to make sure your breakpoints will stay after page reload and whatnot. Debug the application locally. Not only that, but for this specific challenge, as you can see the things here, this might help you. Because we have this function here, which is, where is it? Checkhost, right? This checkhost function that is run, and it checks if the application runs on localhost, which we do have the application running on localhost here. And that check functions will do some things that might be relevant for the solution of this challenge. So this is, if you don't know how to bypass the check function, you just get the application downloaded locally, and there you have it. You have your bypass, and you can, maybe you know what to do after the check function bypass. So you just move on over this. Try to do the other parts of the challenge. So next is there's another way to do it. Like, let's say you don't want to do this, right? You don't want to run the application locally, maybe because it has some server-side components, which some challenges from Integrity have. And the way to do that is by using overrides. So let me show you what overrides is. So override is a way that your browser will serve content locally. So let's say you're opening this page and your browser says, hey challenge.integrity, give me this window maker file, right? It's going to make a request here, right? This is a request. When you set up overrides here, your browser will not send a network request to get this window maker file, but it will load it locally from your computer. So you can set up a folder here where you have the overrides, and you can edit the file locally very easily. So let's do that. So let's set up overrides for the site here. So in the sources tab, we can see there's an overrides panel. Let's select a folder, and I don't think I have anything set up. I think we can create a new folder here. So we're gonna name it overrides. Right, okay. gonna allow it here. And now on the page tab, we can save for overrides. Right click on an asset, save for overrides. Go back to the overrides tab. And now we can edit it inside of so for example, where is that that function, that query string function, right? We can simply type debugger here and then Control S to save it, right? We have the nice start here. Control S. And if we refresh the page, right, nothing happens. Since we did not do that much. Let's see. Just use the application. Generate. Still does not hit. So while working on this challenge, I've hit a Google Chrome bug. When the file name has a space in it, the overrides will not work, right? So this is quite annoying, right? We cannot easily debug this application, right? The specific page here, windowmaker.html. But what we can do is set up overrides for the other files, right? For example, we also have mithril.js here. And we know this file does not have any specific characters that would break the overrides for Google Chrome. And so let's set up that one here. So let's save for overrides. We have it here, right? We have an overrides window of mithril, right? This is the file. And we can Control F query. So query. I think it's parse, right? Parse query string, right? This is the function here. We could just add a debugger statement here. Save the file, right? And now we hit the debugger, right? We hit the debugger here, but we're inside the mithril.js file. We don't really want this. So what we can do here is just use this function here, this button here, step out of the current function. So step out of parse query string, and hopefully we'll go back to, right, we're back inside window.html function, right? We should be able to see, we see the QS object, and let's resume, right? Let's change the window content and see if we're still hitting the debugger. Right, it's still working. So, right, this is a nice trick of maybe it saves you a little bit of time when working on an application. Then you don't need to set up breakpoints every time you change the URL or whatever, right?
Interesting code starts at 193. Up until this point, it looks pretty boilerplatey to me, and I think we get to the juicy parts when things are moving around and we can start tricking some parsing logic at 193. So, okay, I definitely got to look into that. Did I already make a note of that? I didn't. Okay, so this is another thing we're going to do is app config. Maybe that's not as weird as I think it is. What do we call it? Object attribute setting 197 is different. It's a weird syntax. Most people just do a dot. But you never know what kind of tricks exist out there for these types of things. So it's always good just to at least note it down as interesting, and maybe it's completely pointless. Tasks. Next thing will be understand parse query string. Who knows if there's some oddities? Maybe there are like multiple formats that like maybe sometime it pulls out some different thing. That type of thing is quite common. These are just boring strings, boring values, and they're all just hard set. I think main is pretty much our starting point. This feels like the application to me. If qs.config, okay, so that's if it's in the URL, then we are merging all of the stuff we just set with our qs.config, and let's say that is extremely interesting for prototype pollution. So let's see, 206, possible prototype pollution or similar, because sometimes it's not about doing the vulnerability, but taking the same ideas. And then that puts us into custom mode. Pretty interesting. So that's going to be another task. We want to understand that mode. Understand what custom mode does. Yeah, we might do that as our first task because I'm interested in that now. They've piqued my interest. Dev settings. What? The same thing? No, I thought they were the same thing. Okay. Dev settings. All right, so these are settings. It's another object.create null, but with different values. This time we've got root, where we're picking out different roots. Dev settings is debug false. Surely if we're dev settings, if we're using a dev settings object, debug would be true, but still, that sounds like another one to investigate as well. Understand is debug importance. Maybe we can take it out of a safety mode or something. If we're in a debug mode, they won't have the same level of security. Location. Now that is interesting as well, because I did see something relating to location later, but I think when we get to that, we'll make a note on it. Is test host or port? Yeah, both of these were kind of related to what we were looking for earlier, which I think is coming up here. Check host. That's the one we want to look at, so I'll wait until we look at that before I write a note on it. Dev settings is test host or port equals true. All right, so it's checking something about the host. And if so, then it goes into true. So that's going to be our other thing to check. So we want to know what custom mode does. We want to know what is debug mode does. And we want to understand what is does. And then we merge again. Let's add 118 on there because there's two places. 218. Maybe we could do something similar. 218. So if dev settings is test port host, okay, so that's this thing, or dev settings is debug. So if either of those are true, then just console log. Damn it, that's not interesting at all. That's so unjuicy. What's that for?
And I'm gonna leave it at that. Now, all of these people recorded way more footage, so if you want to see the full versions, then leave a comment down below. If you like this video, like it, share it with your friends, and I hope to see you back for another one.